The life cycle of any stars from birth to death and all the stages in between will span millions and even billions of years. That's why stars doesn't seem at all, because human life is just a snippet of a fraction of a blink of an eye to this behemoth.
The path that will be followed by a particular star depends mainly on its mass, or how much gas collected and collapsed to form the star, because that material will serve as the star fuel. As we may remember from physics and chemistry, when nuclei collide with enough energy so as overcome the electromagnetic repulsions between them, the strong nuclear force takes over and they fuse with a small fraction of their mass, converting into huge amount of pure energy as dictated. E is equals mc.
Therefore, only colliding nuclei and fusing them in its ultra-hot core can a star release enough outward energy to counteract gravity crushing inward. This means that the amount of matter that formed the star determining the amount of fuel. Any star begins from a large cloud of a gas and thus at least a few light years across. In the earliest era of star formation, this material was almost exclusively hydrogen and helium, as this was what remains after the brief 17 minutes of nucleosynthesis soon after Big Bang.
This matter collects due to the gravity pushing increasingly inward as it contracts until things get so hot. Over a few million years that the nuclear fusion eventually begins, establishing equilibrium and generating a yellow or a red main sequence star. These fusion reactions begin with two protons pushing followed by subsequent beta decay. So get a proton and a neutron, and we call this a deuteron, which is a nucleus of heavy hydrogen. Then, deuterions are involved in reactions that make helium which have two protons and a neutron. Such a star will continue in this manner for a billion of years, showing fusing all the hydrogen in its core into a helium and maintaining a relatively steady size, temperature, and luminosity as it does. So, until almost all the hydrogen is gone. At this point, things really began to change. The core of the star will shrink and get hotter, which makes the remaining hydrogen bomb even faster, and all of that extra energy being generated will radiate outwards and push the outer layers away from the core. As the outer layer expands, they cool and thus become more inhibitor.
Stars can maintain this new status for a little while longer, around a billion years, but the core gets even smaller and hotter.
The star begins pulsating as it runs through its final energy reserves, entering what we call the horizontal branch, and this time it becomes smaller and hotter and lower until much of the helium has fused into large nuclei. Once the core is predominantly carbon and oxygen with just a shell of helium around it and a shell of hydrogen around that, the star has very little material left to burn, so the core will collapse and the star enter the asymptotic giant branch.
This means it will grow rapidly and become a giant star again, until the last burst of energy ejected the outer layer, pushing it away from the core and back to interstellar medium, leaving only a tiny, very hot bare core behind, about the size of an Earth. This will gradually cool as it has no more fuel to burn, not even hot enough to fuse carbon or oxygen nuclei, and it will contract further until we are left with a white dwarf star. The ejected shell is called G Planetary Nebula, which is misleading since it is not a planet and did not come from a planet, but a name is Planetary Nebula will then become a variable to join more gas particles to form yet another star.